Hi, ladies and gentlemen. I just want to spend a little bit of time talking about some of the items that we have that are integrated with this course, specifically Mobius, as well as the expectations for what we're looking for when we ask for explanations for solutions. So these are the three things I want to talk about. The Mobius syntax. For those of you who are new to Mobius, you want to make sure that you practice with the syntax before you start entering answers and having those graded. The syntax, as it is with any programming language, a little bit different when it comes to Mobius. It's fairly standard, however. Also, I have a better alternative for you than using a calculator. Calculators are basically OBE with modern technology, and I want to give you a demonstration of what that looks like. And then finally, explaining solutions. Historically, the math courses that you've taken are about finding solutions, and we're still going to do that, obviously. However, because of the intellectual nature of this course, you're going to be expected to actually explain your methodology for finding solutions. And I want to give you an example of what that is and what it looks like so that you're clear on the expectations. So first things first, over here we have the course. And what I want to do is just navigate to Mobius. So under course menu, I can come up underneath learning modules. And of course, mine's going to look a little different than yours because mine is set for the instructor format. But right here we have Mobius. And when you select Mobius, you'll be taken to this item here where you go in and you establish your Mobius account and all of that. And then you select Introduction to Mobius. So Introduction to Mobius will take us into the Mobius software. And in here there are a lot of, obviously, educational components for how to use Mobius. What I'm going to do is come up underneath the drop-down menu here, and I want to look at these different items that we have available to us. So specifically what I want to do is I want to look at the things that I highly recommend that you make sure that you go through in order to become comfortable, right? So it's just a series of practice sessions for you to become familiar with how Mobius is expecting answers. So there's a section on entering answers, and then really the rest of these are how to enter different items. Entering multiplication, entering fractions, entering more complex expressions, exponents, absolute values, square roots. So there's this whole series of practice sections, and I want to encourage you to make sure that you go through those so that you're not missing points on problems that you know how to do, but you've messed up on what the syntax is. Secondly, I want to talk about a calculator. So in this, we're not going to be using a calculator, a graphing calculator, right? So when it comes to computation, a spreadsheet is a far better tool to use. And when it comes to actually graphing, there is an application called Desmos, which is available online. And Desmos is an excellent graphing calculator, provides you an excellent opportunity for building a lot of intuition. And I highly recommend that you go and play around with that. Like most of the things available on the internet, it's free. So what I want to do is just talk to you about how we can use spreadsheets to help ourselves out here when it comes to doing these calculations for limits. And let me explain how we can use this. All I've done is pulled up Google Sheets here. And what I want to do is I want to use the standard power of a spreadsheet. I'm going to enter in a 0 and a -1. Most of you are, of course, familiar with this. If I highlight both of these cells and then I grab this, it's going to extend and it's going to provide the pattern that it thinks it's recognized there. So it's going to give me counting down to -6. And then what I want to do is start at -6 and go -5 and count back up to 0. So I'm going to go and grab these two cells and then run these down 3, 2, 1, 0, like that. So now I have a stack of numbers. And what we're going to do is we're going to solve a particular problem. Let me write it down. So what we have right here is a typical problem for the first couple of weeks here in Math 225. And what we want to do is take a look at what happens as x approaches 4. So one way that we could use this stack of numbers, which of course is not going to be very effective, would be as integers, right? We could do, 10 minus this number here, And I'll give you a quick demonstration, but this is not the kind of thing we want to do. So 10 minus this number here, right? And this is going to give me this set. Well, I guess it's actually 10 plus, so let me make that quick change. One of the beauties of the modern programming, of course, and I've fat-fingered this, is it's very easy to make adjustments for these things on the fly. So I wanted to add instead of subtract, and let me just get this going. Right, and then it comes down towards 4, and then I could do a growing type of system here, and we could say, well, you know, maybe here it is subtracting off the values. And the point is, this is not really what we want. We want to use these integers over here as exponents. So what we're going to do instead is we're going to take 10 raised to the power of this number. And we're going to do that all the way down our entire stack here. Okay. And you can see this is going to give us powers of 10. Now what we can do is we can use these powers of 10 to approximate the x approaching 4. What we could do is take 4 minus this number. So this requires an equals 4 minus this number here. And we can fill this out all the way down. And then we could do a 4 plus this number, and it would continue to increase. Sorry, I keep forgetting my equal sign there. And then this will increase. So by using the integers as exponents and then building a column of 10 to the power types of things, right? So these are exponents. And then here we have 10 raised to the power of whatever this thing is here. And then here we're doing 4 either minus or plus the number that we have here. And so you can see this gives us a series of numbers which is coming in and closing in on 4 from both directions, from both what we call the left-hand side and the right-hand side. So this is also a good way for us to do left and right-hand limits, or one-sided limits, which we'll talk about some next week. But now what we want to do is we want to go in and take a look finally at the expression that we're interested in. So in this case, we're interested in the square root of 12 plus the x value, which is our column C. And then we want to do plus the x value, and we want to take and divide this, we want to do minus 4 here, minus 4, and then we're going to divide this by the quantity of the x value minus 4. So when we do that, we end up with this situation here, and notice in Google Sheets it allows us the option to autofill, and we can just select that and it's going to autofill for us. And so we can see what we have for this limit. The point is, we don't need to go into the calculator and punch these out one at a time. We have the power of the computer, we might as well use it. And in this case, we can see that as x approaches 4 from the left and right hand sides for this particular expression, the limit is around 1/8. So in this case, this is 1/8. And we could change the exponents if we wanted to. Remember, that's one of the powers that we also have with spreadsheets. We can come in here and change, and the entire spreadsheet will update, right? So let's say we wanted to be a little bit more precise and we wanted to start with -3 and -4, and then we could drag these things down to a -9. And then of course here we could do a -9 and a -8, and we could drag these down again in order to update, just like this. And then you can see we have our numbers here that have updated. We have a smaller number that we are subtracting or adding relative to 4. And so this is the limit, and we can see the limits from the left and right hand side are equal to 1/8. Also, another advantage with the spreadsheet is, what if we want to change the problem? What if instead of this problem we want to look at, instead of a -4, what happens if we put a -x in here? What do we get when we replace the 4 with an x value? Because we're interested in x going to 4, is this going to give us the same limit? Well, we can come right in here and change the -4 to an x value, just like that. So we update that equation, and then we double click on the bottom right hand corner here and it will fill up below. No, that's an Excel thing. So here we're going to drag. So here we drag this all the way down and we can see that the limit has changed. It still has a limit. From the left and right hand sides, it's closing in on -0.875, which is not the same. In fact, that's -7/8. So for our pink problem, we have a different solution. These are the types of things that we're talking about. And for number 3, the explanation. This is the type of problem that you can expect to see. And it's not just enough to write down 1/8 or -7/8. There's going to be a requirement to explain how did you do this. And so that's as straightforward as saying, hey, I built this spreadsheet. I looked at the left and right hand limits. And I see that the left and right hand limits are equal to one another, and they're both equal to whatever the value is. That's the type of explanation that we're looking for. Thank you very much, and I look forward to working with you this course.